So one thing that was very interesting that I told you was here. That the energy of a photon is a function of its frequency. That means as the frequency changes, the energy of a photon changes, which means the photon itself sort of changes. So in order to take into account these many differences, we had to come up with a hierarchy of what we mean when we say a photon. So I have given you a handout. On this handout, there is a list on the first page. That is called an electromagnetic spectrum. So light, as we generally know of, the visible light, is only a tiny portion of this entire electromagnetic spectrum. Do you guys want to start at the top? Oh, also, note up here, equation 2.1. Do you see C equals lambda nu? I generally not call it nu, but I wanted to leave that here. That's sometimes physicists like to use the word nu, but I get confused between my nu's and my v's when I write them. So they will say nu for frequency, but I tend to call my frequencies F just because it's easier for me to recognize with my handwriting. See, my nu's and F, look at this. When I write my nu and my V, they both look the same to me. So I tend to get confused. So speed is also a V, right? And nu is also sort of like a V. And if I'm not careful, I get confused. So for my nu, for my frequencies, I just call them F to make sure I don't mess up. But if you look at this equation at the top, you see that this is C equals lambda nu, where nu is what they call frequency. If you want, just change it to F so you don't get confused. Or if you want to keep calling them nu, I have no objection. Either one, whatever you feel more comfortable with. How many people would like to stick with F for frequency? Okay, great. So let's just change this now to F. Okay, it's the same thing. Okay, so do you see this? Let's see, I'm looking at this graph. What do you read at the top? Meters and hertz. Yeah? Hertz is a unit of, and meters are units of wavelength, right? So 10 to the minus 16 meters for a wavelength is very tiny, which means smaller wavelengths should have the higher energy. Got it? And so now look at what it says for the type of photon it is. Gamma rays. So gamma rays have very, very small wavelength, but very, very high energy and also very high frequency, right? Coming down, what do you read in the middle? So I'm sort of reading the middle part and then going off to the other two sides, right? Actually, I might have this picture somewhere here as well. Oh, it's flipped. But it's like I'm reading these gamma rays here, starting with these gamma rays here, and working our way backwards towards lower and lower energies. And correspondingly, I'm looking at those frequencies. As frequency is going lower, the energy is going lower. But as the wavelength is going lower, the energy is going higher. But look at the actual visible light in the middle. So see the very small slither in the middle of your picture? Yeah. That's your visible light. Out of the entire spectrum of electromagnetic radiation, the visible light comprises of about this much. This is what humans are tuned to. The higher the wavelength, the lower the energy. So is red more strong or blue more strong?
Blue.
Blue is more energetic. Okay? So have you ever thought about why the red lights, the warning signs are all red? Because they travel further, right? They're they're towards the lower end of the spectrum, and they will travel further than any other light that we can see. Radio waves, they are all around us all the time, all our cell phones, everything, right?
Yeah.
They are less dangerous. Why? Because they are lower frequency, higher wavelength. That's why they travel. So FM and AM radios, right? Which has more noise? AM radios have more noise, right? No, more background noise, but they diffract more. They travel around buildings better. FM radios do not. They have a higher frequency. They don't diffract as much. That's the same reason why higher pitched voices, you can't hear around the corners as well as so you can hear men talk mostly around corners, but you won't hear women talk. They're higher frequencies. So this is a good slide to know. Oh, it's not. It's just so you know where things come from.